of machine learning algorithm implementation case study, namely detecting pork adulteration in beef for halal authentication using electronic nose and machine learning algorithm. After this case study, Dr. Ratimala also will explain another case for machine learning implementation. Okay, in this session, I will also show you a simple implementation of machine learning algorithm using Python to perform classification tasks for meat adulteration detection. Yeah. If we read several references, yeah, driven by economic development and urbanization, animal-based protein consumption has surged worldwide over the last 50 years, reaching from 81 gram per day in 1961 and to 80 gram per day in 2011. Yeah, this contribution analyzes the apparent convergence of dietary model worldwide with respect to proportion of animal-based protein and especially meat intake. Yeah, they emphasize the surge in animal-based protein intake in emerging countries, including China and Brazil, which has partly replaced plant protein. However, for similar degrees of economic development, the composition of animal-based protein and the position of meat within this category vary significantly among countries, suggesting that historical, geographical, cultural, and religious factor may be involved. Yeah, so we have several issues, including for some certain religion, they are obligated to know the source or the purity of meat that they consume. Hence, ensuring the quality and purity before consuming meat is very important. Yeah. Yeah. For example, for some certain religion, they are obligated to know the source of meat they consume. For example, it is taboo for Muslim and Jewish to consume pork, while it is prohibited for Hinduism to consume beef. Yeah. Yeah, according to this background, in this research, we use electronic nose to get the data from odor that produced by beef and pork. Yeah, electronic nose is one example of instrument that comprise of several number metal oxide semiconductor gas sensor, which has different selectivity to detect various gas sample in the sample chamber. The mechanism of electronic nose is similar to how human sense of smell work. For example, in electronic nose has a sensor array that consists of several gas sensor with different selectivity to detect odor molecule from the air, especially in the sample chambers. And then the signal from sensor array will be sent to olfactory bulb to perform feature extraction, and pattern recognition module will act as our brain to recognize the kind of sample or odor. Yeah. Yeah. I will explain the material that used in our experiment to acquire the data set from the mixture of meat and beef and pork. We have or we use several gas sensor with different selectivities. Uh, for example, we use MQ2 gas sensor with the selectivity including LPG, isobutane, propane, and alcohol. And then we also use MQ4 gas sensor to detect methane and natural gas. And we also use DHT to sensor to detect the temperature and humidity in the sample chamber. In this study, the total sensor use is 9, uh, and and each sensor has different selectivity to detect different gases. And this gas sensor were assembled to an Arduino microcontroller, yeah. And for data communication, we use universal serial bus or USB interface to transfer the signal from gas sensor to the computer. And then the gas sensors were placed in a sample chamber that made from transparent glass. Uh, you can you can see in this picture. So uh, we can observe the sample, the mid sample in this sample chamber. And then we perform experiment with several experimental stages. The first stage, yeah, electronic nose was turned on for uh, 15 minutes for preheating because we need to preheat the gas sensor for optimum detection for particular gas. And the second stage, the mid sample, the mixture of beef and pork was placed in the sample chamber with gas sensor array. Yeah. And the third stage, yeah, the process of data retrieval and transfer to computer using USB for 15 to 20 minutes for each sample. So we have several samples with different mixture between beef and pork. So we repeat the experiment in several times to get more data from single sample. And for states, the sample chamber was cleaned using a flashing fan about 5 minutes to make sure the residual gas in the sample chamber is empty. The samples used were ground beef and ground pork, both in fresh condition from the same store on the same date. In this experiment, the samples of 7 combination of pork and beef were used. So we have 7 classes, yeah, in this problem with different mixture, with different composition between beef and pork. The first and 7 classes were 100% beef and 100% pork respectively. And then the second, yeah, the second, the third, the fourth, 5, and 6 class contain pork with 10 gram, 25 gram, and class 4 is 50 gram, and class 5 contain pork about 75 gram, and classic is 90 gram. And actually the last class 7 is the pure pork. So we have 2 class that including class 1 with 100 gram of beef, and class 7 is 100% of pork. Yeah. So in this experiment, we got data set with multi-class, ya, multi-class for multi-class classification for halal authentication. Ya, yeah. This is the sample of signal response from each gas sensor. Yeah. For example, we can see the response from MQ2 gas sensor is different with another, yeah, with MQ4, MQ6, and so on. This signal response is depend on the beef sample. So according to this signal, to this data, we can classify 7 classes of beef and pork mixture. The detailed description of our data set can be read in our data article in Science Direct. The title is Electronic News Dataset for Pork Adulteration in Beef. Yeah, so all of you can read and use our data set for exercise, yeah, for research. This data set is available in Mendeley data. So you can download the data and feel free to use for exercise or research. Yeah. Okay. In this course, we will use a simple machine learning algorithm to perform multi-class classification tasks, especially for halal authentication, yeah, for to detect the mixture between beef and pork using support vector machine algorithm. Yeah. And this algorithm is simple, but I think is one of powerful algorithm, especially for classification or regression tasks. Yeah, the basic concept of support vector machine is spirit the data using hyperplane, using optimum hyperplane. Yeah, to determine the optimum hyperplane, support vector machine will use support vector with the bold borderline. Yeah, for example, in this picture we have 3 support vector. Yeah, and the data is spirit using a linear hyperplane. So we have in this example, we have 2 classes, the blue class and the green class with classify using support vector machine algorithm. Yeah. In support vector machine, we also can use several kernel function, yeah, to differentiate the data in the nonlinear way. In default, super vector machine will spirit the data using dot product or linear kernel. So we can realize that the data set, yeah, all of data set, both public or we perform our experiment is spirit by nonlinear boundary. So if we use linear hyperplane, the result will be not too optimum. So we also try another approach, including of kernel function in support vector machine. For example, we can use radial basis function, yeah, for nonlinear kernel with 2 parameter, C and gamma. C means regularization parameter, and gamma is parameter if we use radial basis function. And then we also can use sigmoid, yeah, sigmoid function for SVM kernel. If we use sigmoid kernel, we have 3 parameters, including C, gamma, and R. Yeah. And the last, we also can use polynomial function. Yeah, a polynomial function. If we use for SVM kernel, we can we have 4 parameter C, gamma, R, and D. Yeah. We also can use our own function for kernel, for SVM kernel. For example, we develop method, yeah, or function for SVM kernel. We can also use our own kernel function for classification or regression task using SVM. Yeah. So I think SVM will give flexible solution when the data is spirit by can be spirit by linear hyperplane. We just use dot product, and if our data set is spirit using nonlinear hyperplane, we can use RBF, sigmoid, or polynomial function, and we also can use our we can use our own function. Yeah. Okay. In this section, I will show you the simple implementation of machine learning algorithm to detect a mixture between beef and pork by using Python 3, Google Colab and Google Colab, yeah, for IDE. And also we need several libraries uh, such as we use scikit-learn, yeah, scikit-learn. This is popular library for machine learning for supervised and unsupervised. And we need pandas, especially for ETL, extract, transform, and load data. And we also need matplotlib or seaborn for data visualization. And then we need joblib for persistent model. Persistent model means we can save and load our model after training. Yeah, if we perform training, machine learning training, we got the best model, yeah, with the best parameter, hyperparameter, and we can save this model, and then we can deploy to uh, web apps, yeah, or mobile apps. So we not need to train and train again, because the most or the best model is already safe. Yeah. Yeah, to build a machine learning model, yeah, I say this is a simple, yeah, this is simple. We perform multi-class classification by using SVM model, and then the final objective we can save our machine learning model, yeah, to deploy into web application or mobile application. The first step, yeah, you can see in this figure, yeah. The first step, we need to load data set, yeah, especially data set that has 7 classes that I explained before, yeah. And the second step is we need to perform data preprocessing, yeah. Maybe the data is has different scale, yeah, different range of values. So we need to uniform the scale to make the data is ready uh, for training. Yeah, and the third step, yeah, we also uh, perform hyperparameter optimization. Yeah, uh, I will back to previous slide. Yeah, we can see if we use nonlinear kernel, for example, RPF, sigmoid, and polynomial, we have several parameters. Yeah, so in this case, we need to make sure each parameter it has the most optimum value. Yeah, we need to determine. Yeah, we need to find uh, the best value of this each parameter. So we need to perform hyperparameter optimization. Yeah, and then the the fourth step is evaluation. Yeah, for evaluation in classification, we use typical metrics, including classification accuracy. We also can use precision, yeah, recall, and F1 score. Yeah, so we can use several metrics to make sure that our machine learning model uh, is it has good performance in according to the various performance metric. Yeah, and if evaluation process is finished, yeah, we can see, yeah, we can see the result, and we can determine, yeah, the best model, yeah, the best machine learning model, and then we can save, yeah, the best model by using job leap, yeah. If our model is already saved, we not need to train and train again. So the model is persistent. So the safe model we can copy, yeah, we can copy into our infrastructure, including we can deploy this model in our notebook, yeah, laptop, or we can deploy into server or cloud, yeah. Okay, I will show you the how to develop a simple machine learning algorithm to perform multi-class classification task. Uh, Maybe uh, uh, you think, oh, it's very difficult, but I will make sure that this implementation is not really complicated. Yeah, it's easy. Yeah, machine learning is easy because we only need to call the function from scikit-learn, yeah, or if you want to use a deep learning, maybe we also can call the function from Keras or TensorFlow, maybe, yeah. But in this section, I will show you how to develop machine learning model using scikit-learn, in particular using support vector machine algorithm. Okay, the first step we need to load all of library that used in this experiment. Yeah, I already explained, yeah, before in my slide. For example, we need pandas, especially pandas data frame to extract, transform, and load data. And we also need to import Seaborn or Matplotlib for data visualization. And the most important thing, we need to import several several function from scikit-learn. For example, we need to import a preprocessing module. Yeah, we need preprocessing, especially for feature scaling. Yeah, we will use standard scaler. Yeah, and then we need to divide, yeah, our data set into two parts, namely training data and testing data. Yeah, so we need split our data set into two part. Yeah, training and testing data. And then for hyperparameter optimization, yeah, we can use grid search CV. Another method for hyperparameter optimization is randomizers, but in this experiment we use grid search. Yeah, and for evaluation, yeah, we need classification report. Yeah, to to know the performance of our machine learning model. Yeah, we can use this function, and of course we need import the SVM library from Scala. Yeah, we will import SVC, support vector classification. Yeah, in this experiment, I already upload the data in my Google Drive, yeah, and then the dataset file we can load by using Google Colabs. Yeah, I will first I will show you, yeah, the dataset. Yeah, yeah. The dataset is already uploaded in this Google Drive. So we can easily load this dataset into our notebook by using Google Colabs. Yeah, yeah. This is the location of our dataset. Yeah, the dataset format is table uh, that contains rows and column. Yeah, yeah. In this dataset example, we have several columns. Yeah, for features. Yeah, or predictor to predict the class of label. Yeah. Okay, maybe it's too small. I will zoom. Okay. Yeah. We can use several column as features or predictor. For example, we can assume that MQ2, MQ4, MQ6 until MQ138 as features or predictor. And this feature, uh, uh, by using this feature, we can predict the level, yeah, class 1, class 2, until class 7. Yeah. Okay. This is a program, yeah, a script for dataset load, yeah. We can easily load the dataset file that placed in Google Drive by using this path, yeah. Uh, yeah, I use data frame using pandas data frame for dataset load, yeah. Yeah. So if we run this cell, we can get the dimension data dimension of this file, yeah. If and POC monitoring 2.xlsx. Yeah. The number of rows is 120 and the number of column is 13. Yeah. We also can show the example of data. Yeah, this is similar with the data uh, that contains in this file. Yeah, it's similar because it from single source. Yeah, similar source. Yeah, so we can see in the column the features and also the label. Yeah, we will use the features. Yeah, these features is sensor response, yeah, gas sensor response to predict the class level. Yeah, yeah. The next step is pre-processing. Yeah, uh, first we need to spirit the features column. We will create the x variable to to save the value of features, ya, column 0 to column 8, ya. We can apa? We can assume that this column is features, and actually the label, ya, the label column, ya, the label column that contains the 7 classes, ya. Yeah, we save into y variable. Okay, after we spared the features and label, yeah, we need to uniform the scale of features, yeah, using standard scalar. Yeah, so we create scalar variable is instantiation from standard scalar function. So then we just need to call scalar dot fit x, ya, x mean features, ya, and finally we call the transform function, ya, to transform the original values into scaled values to make sure all of column has similar range, ya. Yeah, this is the result of feature scaling process. Feature scaling, several people also call normalization. This is same thing, yeah. Feature scaling is equals to normalization. It is a similar term, yeah. Okay, we get uniform range of features. This data produced by feature preprocessing process is ready for training. Yeah. The next step, yeah, if our data is ready, the next step is parameter optimization process. Yeah. Hyperparameter optimization process will make sure that our machine learning algorithm is fine-tuned, yeah, by using the most optimum parameters, yeah. So if we use support vector machine, yeah, we can determine the C values, yeah. We can search in the searching spaces, yeah. For example, for C, yeah, we will search the value 1, 10, 100, yeah, and so on. And gamma, we will search the optimum values, yeah, in this grid, yeah, in this grid values. And in this experiment, we will use RBF or radial basis function, yeah, to perform multi-class classification task, yeah, for halal authentication. Yeah. Yeah. Okay. This line means we will divide the dataset into 2 parts, yeah, including data training and data testing. Yeah. So we can easily call this function, yeah, train test split, yeah, from scikit-learn to divide our dataset into 2 parts, yeah, 2 part for training and testing. So we also can determine the proportion of our data for training and testing. We just set the test size equals to 0.3. It means that the proportion of data testing is 30%, and for data training is 70%. Yeah, I will give a note for you. This the script means 30% for data testing, yeah, and 70% for data training. Yeah. If you not want to use this proportion, you can easily change these values. For example, you want to 25% of data testing and 75% for data training. It's up to you. But the best practice in this experiment, I also use 30% for data training and 70% for data. 30% for data testing and 70% for data training. Yeah. Yeah, and then we just define the variable of our classifier by using this function in this experiment. We use grid search CV for hyperparameter optimization. Yeah, so the classifier will be get the best model from grid search CV. So if we use classifier or model result from grid search CV, we can make sure that our model is the best or the most optimum model that has optimum hyperparameter. Yeah. So we just call grid search CV, and in this experiment we use support vector classification SVC, and we need to apa param grid for search spaces, yeah, for C, gamma, and kernel, yeah, and then we just call classifier.fit for model training, yeah. Yeah, we put the xtrain means the features for training, and ytrain for label for training, yeah. And we also can print the base parameter from grid search CV. Yeah, and in this program, we also can predict, yeah, can predict the result, the final model by using the testing data, yeah. X-test means testing data with proportion is 30%. And then we also can print classification report to know the several classification metrics, yeah, including classification accuracy, precision, recall, and F1 score. Okay, we also can show a confusion matrix, yeah, for more detailed prediction. Yeah, okay, I will run this cell, yeah. Yeah, the process is really fast because the data is not too big, yeah. So the training process is relatively fast, yeah. We can see in this, yeah, in this cell we got the most or the best parameter is C is equals to 10, gamma is 0.1, and kernel is RPF. So we get classification report, yeah. We can see the score of precision, recall, F1 score, yeah. And we also can see the accuracy, yeah. the accuracy is high, 98%. Yeah. We also can see confusion matrix, and this is confusion matrix. The x-axis, the x-axis is predicted labels by using machine learning model, and the y-axis is actual label or true label, true values in data set. So we can see that almost of our data is accurately predicted, in in this diagonal values, and we only only have two data with wrong classification in class 4. According to this result, we got a relatively good machine learning model with 98% of classification accuracy, and we also can see the score of precision and recall. Almost of them is show the good performance of our machine learning model for 7 class classification. If we satisfied with this result, we can save this machine learning model using a job leap. So after we save this model, we can deploy the model into our cloud infrastructure for web application or for mobile application and so on. I will save this model in my Google Drive, in this directory. The name of file is enoshalalmodel.sfe. We just need to call joblib.dump. The classifier is variable, model variable that we have defined before. This one classifier. Classifier is the result of hyperparameter optimization. Okay, we will run this cell. So we can see that the comparison between safe model, by using joblib, it got 98% of classification accuracy. This result is same with if we use direct training model. Direct training model means we not use loaded model. The original model from classifier variable. We can see and we have verified the result is same. It means that it is no problem with our persistent model, because they get the similar result. Okay, we can see the safe model, in this directory, dataset ilmu data. Nah, this is the file that we got from our experiment. We can download and deploy into our laptop or our server for machine learning application. We can develop user interface by using web application or mobile application. It's up to you. We can use this optimum model. Okay, it is from all of my presentation. Thank you for participant. Okay, we will continue for this material, this course with Dr. Ratimala. Yeah, thank you.
Okay, good afternoon or good evening, everyone. Can you all hear me clearly?
Yes, Doctor.
Yes, we can.
Okay, thank you. Okay, so hope everyone is doing good. So before I start mine, I would like to ask you one question through the poll. So I'm going to launch one poll. So in your Google Meet link, you will see one question. Are you all seeing the question? Do you see any question over there? Okay, just hold on. Now, I have launched already. How about now? Yes, thank you. Can I have an answer from you all? Because we have almost 192 participants. So before I go into my topic, I would like to know how many of you are already aware of what is machine learning, what can be done with that, or I do not know. I have heard about it, but I have no idea what we can do with machine learning. Okay, so I can see there are 45 participants have already answered. We have 192. So at least 50% of the participants. I'll wait for your answer. Come on, are you all able to see the question or not in your Google Meet link? Okay, so I will stop when I get 100 responses. Huh? So as of now, I have 58. Where is the link? You will see in your Google Meet link. There will be a poll pop up from your Google Meet link. No link? But there are students already, participants already responding to my Go. Yeah, it is in the Meet. In your Google Meet, you will see the question. There's a poll. Poll activities. Okay, thank you. Okay, maybe some of you are new to Google Meet. Okay, so I have 80 responses so far. '87. We have 192 participants in this Google Meet now. Okay, so from what I can see here is almost 78% of those who have responded, they already know what is machine learning. All right. But there are almost 15% they said, no, I don't know what is machine learning. Okay. So I just want to know the background of this participant so that it will be easy for me to emphasize which part to emphasize. That's the reason I raised this poll question. Thank you so much for those who have answered. So I'll end the poll. Okay. So I have already shared my page, right? Can you all see my screen? Yes. Thank you. So I'm going to also discuss with you all about a case study which uses machine learning to get some insights. So the title is Identifying Households Who Desire a Moratorium Subsidy from an Economic Stimulus Package Using Machine Learning. And myself, I'm Dr. Ratimala Kannan from Multimedia University. So I'm the program coordinator for a bachelor degree called Bachelor of Digital Enterprise Management, which is a combination of more IT and with business and management subjects. So here you have my contact email. So if you have any doubts later from whatever I taught here, you guys feel free to contact me. Okay. So now let me give you some background about this case study. Okay. So this is again, the problem comes with our COVID-19, right? Throughout the world, every country has got affected by COVID-19, correct or not? Yes. So now, when you have such a pandemic kind of a disaster, which is devastating for individual, right from the individual people until big business companies and all. Right? So when you have such a pandemic one, how the government from each country can help its citizens to lessen their burden. Of course, we all know many government, they have come up with different kind of economic stimulus packages, right? Do you have economic stimulus packages in Indonesia? Yes. So in Malaysia also, the Malaysian government introduced a economic stimulus package called Perhatian Rakyat Economic Stimulus Package to reduce the burden from this COVID-19. Right? So what type of impact this COVID-19 has caused you? For example, you as university students, you cannot continue your life as usual, right? You cannot go out, you cannot go to university, you have to stay at home, can attend all the classes through online. This is how you suffered. Am I right? As a student, right? Other than that, there is no big impact for you with the COVID-19. Maybe you miss your friends, you miss your hangout, going outside and all. But you see on the other side, there are many people who are middle level of income earning or the lower level. We call this low income people, right? So how it would have affected them? Some people, they don't have money to eat the next meal. Am I right? So if some people have some saving, they do not have shelters where to stay. If they have food and if they have shelter, then they are suffering with the problem of how to pay the bill, right? Because the source of income is totally stopped. They are not able to go to job, they lose their job, or their salary is reduced, or they don't get job every day. So they don't earn like before how they were earning through your pandemic, right? So when you have this type, different type of households, they have different type of need, correct or not? Yeah. So when you have, if a government has to support its citizen, the government will think in many different ways, right? Then it will discuss with the high people, then they will come up with some package. Okay, if you give this type of support to our citizens, they will feel good. They will be able to manage, right? So like that in Malaysian government, they were giving some 7 type of subsidies to Malaysian citizens, okay? So if you look at the subsidies, the very common one is cash assistance, right? Obviously, everybody, if you give cash, they said, okay, right? Do you think anybody say, I don't want cash assistance? What do you guys think? Most of the people, they prefer, they want cash assistance. Yeah. So apart from cash assistance, because government cannot give cash to each and every household, right? So the government has to plan well. So what is the next option? Then the government can come up with utilities discount, moratorium discount. Do you know what is utilities discount? Who is paying bill for your electricity, water and all every month? Yes, right? So if there is some subsidies for your utility discount, for example, for different range of people, the government says, okay, you can pay only 50% of your utility fee. That would be helpful to the individual households, right? So they have some money. Another one is moratorium subsidies. We all know what is moratorium subsidies? You guys know what it is? No? Yes? Okay. If you borrow loan for housing loan or educational loan or to buy a car or to buy a furniture, you have to pay monthly, right? From where you borrow the loan. Am I correct or not? So in those times, let's say now pandemic, there is no income, people cannot go to work, then but still you need to pay those monthly installment, right? How do you able to pay? Some people, they have small saving using which they can eat, so food is not problem, but they will suffer to pay the monthly payment, right? So the government says that okay, for next 6 months you don't have to pay, so you can start paying the installment after 6 months. So in this case, you are saving the 6 months straight. You don't have to worry about monthly payment. Correct or not? So this is called moratorium. Apart from that, we have something called EPF cash withdrawal. Have you all heard about EPF? Who has EPF? If we are working, right? So the government will give you EPF, right? So why the employee will put some money and the employer will put some money? Why? Because this money will be accumulated. Then when the person gets retired, after the retirement age, there is no more source of income, right? Then still the employee, the citizen can live a good, decent life even after his retirement. That is the reason why we have something called EPF. All right? Yes. So the during this pandemic situation, when you are suffering with the cash financially, so then the government allows you to withdraw some money from your EPF. So then we have similarly we have credit guarantee scheme and wages subsidy scheme. All right. So like that, government has come up with some package of subsidies, and the government is offering. So this kind of subsidies was issued to Malaysian when we have started the pandemic. That means 2020 April. So first, the Malaysian government conducted a survey to ask the citizens what type of help you need. Are you prepared to face this pandemic? Do you have enough saving? Right? So like that, they have conducted a survey where 160,000 people, they have answered that. So after that, the government issued this kind of a package. After implementing this package, then after 1 month in April 2020, the government conducted another survey to see to what extent these subsidies was helpful to you, which subsidies was helpful to you. So the government collected the data. So this time we had 40,000 people who answered this survey. So this is the background. So why am I explaining all these things? This is the data we have. Okay, as you know, for machine learning, data is the main ingredient. Okay, only when you have sufficient data, you will be able to apply machine learning, and you can extract insights which could be useful for many different things, for strategic thinking, strategic management. Okay, so now, so I have this data set which I got it from the Department of Statistics Malaysia. Okay, so now, what is the problem we have here? As you see, every middle class family or low income family, they will not have lots of savings, right? What do you think? You have lots of savings or lots of debt. Every month you have to pay for electricity, pay water, pay to your monthly installment, pay there, pay for a car loan, pay for a house loan. Then at the end of the month, you left with no money. This is the normal scenario for any normal house. Am I correct or not? Is it anything different? It is a common scenario throughout the world, right? So now, in this case, when individuals having different kind of need, different kind of a support to deal with this pandemic effort, so how we can get help of this machine learning, that if we are able to identify which type of individuals they like moratorium subsidies, for which type of individuals that cash assistance will be helpful. If we are able to predict before we implement this, then we can give a customized economic stimulus package to individuals using which they can handle the pandemic effect better. Is it possible or not? What do you guys think? Yeah? No idea? Okay, so now what we are trying to do in this case study is we are trying to apply data analytics and machine learning techniques on this survey data to come up with the classification model to classify whether this individual person will prefer a moratorium subsidy or not. I am predicting whether he likes moratorium subsidies or not. Okay, so if we know which type of individual people, individual households, they prefer to have moratorium subsidies, then we give them moratorium subsidies. Who prefers this utilities discount, then we give them utilities discount. So in that way, we can customize their economic stimulus package. So the government can support its citizens more better way. Okay, so that is the problem, and this is what the solution we are proposing. Of course, we apply data mining and machine learning techniques. Since 80% of the participants answered that you already know what is machine learning, so I hope you would understand what is the meaning of this. But there are small 20% who do not hear about what is machine learning. So I just briefly explain what is this, what is this. Okay, so if you look at this, we call this as a data mining. Why suddenly from machine learning you call it as a data mining? Because actually the concept is you are mining the data to get some valuable insights, to get some valuable knowledge, right? That's why the term is data mining, which we have been using maybe last 15 years ago, but now the data mining word is slowly faded out, and now it is being replaced with the term called data science. Have you all heard about data science? Yes. Very good. So now, broadly, we can classify what data mining can do as supervised and unsupervised. Okay. So what is supervised? Supervised means when you look at your data, if the data has examples of what you're looking for, then we call that as a supervised learning. Say, for example, in my data set, I have I have that in the survey data, I know which type of individual they said I prefer moratorium. Which type of individual they said I don't prefer moratorium. Instead, I want utilities discount. So I have the examples of people who prefer moratorium and examples of people who don't prefer moratorium subsidies. Okay, so when your data has examples of these two, then we call that type of data mining problem as a supervised. We call that a supervised learning, supervised machine learning model, or direct data mining model. Okay, we have another one is when you don't have any examples, right? But you have huge volume of data, and you want to know how can you make use of this data. So in that case, what we can do is first we try to divide the data by grouping the similar cases in one cluster. We call that as a unsupervised learning, because the data is not giving you any example. You have some data, so you have to find on your own what kind of a knowledge is hidden in the data. So that is a different process. So under unsupervised, you have something called clustering, and you have something called affinity analysis. So since my case study follows this, so I will explain only this part. Is it okay? So since I have examples, my case study, my problem falls under a supervised data mining model. Under supervised data mining model also, we can classify broadly the problem as a classification problem or regression problem. So what is the difference? If your target variable is a nominal data, then we call that as a classification model. What do you mean nominal data? For example, here, do you like moratorium? If that is the question, the answer will be yes or no, right? So this is called as nominal data or categorical data. So my problem falls under classification method. So what is the example of regression? If your target variable is a number, numeric variable, that you want to predict a numeric variable, then we call that as a regression model. A simple example would be currency exchange prediction, stock market prediction, predicting what will be the profit for next month. All those things are number. So these kind of a prediction falls under regression model. So far, okay? Okay, so now under the classification, we have many machine learning algorithm which can be used for classification modeling. Okay, so in this case, I have used decision tree, random forest, naive Bayes, and gradient boosted tree. So these are the four classification algorithm that is used in this data set. So now let's see how you can carry out a data mining project or data science project like this. Okay, so there are different process, standard process that you can carry out. The most popular one is called as cross-industry standard process for data mining, which in short is called as CRISP-DM. Okay, so basically it has 4-6 phases in the project. So if at all you want to carry out a data mining project, data science project, you need to follow these 6 phases. What is the first phase? The first phase says business understanding. So in the business understanding phase, what you are doing is, first you try to understand what problem you are trying to solve. Okay, so what problem I'm trying to solve? I want to come up with a prediction model to predict whether an individual will prefer a moratorium or not. Right? So that's the business problem. Then I can convert that into a data mining problem, which means I want to come up with a classification machine learning model to predict whether an individual likes a moratorium subsidies or not. So once you are clear with what is your business problem and what data mining method you are going to apply, you are done with your stage 1. So far, okay. The next one, the second phase of this CRISP data mining is data understanding. In the data understanding, what you do, of course, you will collect the data which could be used to answer your problem that is identified in your first phase. Okay, so here my data is survey data collected from Department of Statistics. So this data was collected from April 10th to 24th of 2020. So in the survey, there are actually 4 categories with 36 questions. So the total number of respondents were 41,386. But do you think the data is ready, so immediately I can go and apply the machine learning models? No. When you collect the real data, you will be having so many problems with the real data. The data will be raw. So what do you mean by raw data? You will have missing values. You may have some incorrect values. Missing values, you all understand, right? What do you mean by missing value? If somebody is asking what is your age, not everybody will give the age, right? So I don't want to give my age. So I leave the space as blank, right? So like that, many people also they don't want to give age, then they will leave it blank. So here you have many missing values. Correct or not? And sometimes some people say, what is your age? I put my age is 999 or my age is 150. Is it correct? So these type of examples are known as incorrect values. So the real data that you collect from the primary data, you'll have all these kind of a problem. So you need to clean all these things, improve the quality of your data, which we call as converting from the raw data into a structured data, which is the most time consuming process in the data science project. How much time it consumes? Can you see? Almost 70 to 80% of the total project time is spent on this phase. So if you have a good quality data, lucky you can do it faster. If you have very problematic data, then that's it. You're really going to burn your oil. Okay. So once you're successfully done with your data preparation, the next one we go for modeling. So in the modeling, what you will do, you will split the data into training data, test data. That how nicely Dr. Teddy was explaining just now, right? He used Google Colab and using the Python programming, he was nicely explaining how you will import the library files and how do you partition your data set into 30% test data, 70% training data. All right. So all those things are done in this modeling phase. So what would be the output of this modeling? You will have the best model by tuning the parameter of each of the model. So with the best optimal parameter setting, you will know the best model and to what extent it can predict. So once your modeling stage is done, then you need to evaluate, because you are not using only one machine learning model, right? You are using many. So in this case, myself, I have used 4 different machine learning models. So then I have to find out among these 4, which model is the best, which can correctly identify, correctly predict whether the household prefers moratorium subsidies or not. So that evaluation is done here in phase 5. So as Dr. Teddy mentioned that we have certain performance evaluation measures for machine learning, which is precision, sensitivity, F-score, accuracy, and all. Okay, so based upon that, you will choose the best model, then the best model will be recommended for the next stage, which is your deployment stage. So this is how a complete data mining project is done. Okay, I hope you have an idea now how things are working here, what to do first when you are really planning to do the data science project. Okay, so after like this, so I'll just show you some results. Okay, so what results here? This is before you apply for your machine learning. We call this is exploratory data analysis, or we can call this as descriptive statistics or descriptive analytics. Why? So you don't need any machine learning to find out simple graph, right? You all know when you have data in Excel file, how to create a bar graph, pie chart, scatter plot, right? Okay, the answer, questions answer, I will come at the end, okay? So now here, if you look at here, among the 7 subsidies, okay, the highly demanded, highly wanted subsidies is what? Cash. Of course, there is no reason to explain why, right? Everybody prefers to have cash assistance. Next to that cash assistance, you see, 58.5% of the total individuals who answered that survey, they prefer moratorium subsidies. Then if you look at utilities, discount was preferred by 45.9, almost 46% of the respondents. Then if you look at it, it goes slow, declining. So EPF, 39.9% of the total respondents only prefer to have UPF withdrawal. Wages subsidies only 13.3. Credit card guarantee scheme only 8.0. So now we know among the 7 subsidies is given out, which subsidies is highly wanted, which subsidies is least preferred by the individuals. Am I right? So after this, because of this only, we plan to do a classification model for this moratorium prediction. So the first table that I'm showing you explains you how how do you identify the parameters, the optimal parameters in which that particular machine learning model is giving you the best performance. So for example, here, if you look at here, the machine learning applied shown here is decision tree algorithm. Okay. So when you use decision tree, how you can optimize the parameters, hyperparameters. One thing is you can tune the partition ratio. What is the partition ratio? How do you original data set? How do you need to split it as training data set and test data set. Okay, for any supervised model, you need to split the existing data set, training data set into test data set. Training data set is used to learn the concept. So you will give this training data set to the machine learning model. So what the machine learning model will produce as an output, the concepts, the machine learning model will give you the model which can predict the unknown cases. So already the machine learning model is supposed to learn from the data about the concepts, then it will use that knowledge to predict. So the test data is used to test how good is the machine learning model. Okay, so when you do that, see, you will parameters, you will change, but you can change the parameters like this, like you can split equally 50% training data, 50% test data, or you can increase 60% training, 70% training, 80% training. See, basically from the industry, the rule of thumb is when you divide the data into 70%, 30%, most of the time the models are giving you the best performance. But that is not true always. So we need to confirm under what kind of a partitioning ratio this model is giving you the best performance. So this is what we call as parameter tuning. Okay. So by doing so, we calculate all, so this is the target variable moratorium. We calculate all the performance evaluation measure, precision, sensitivity, F-score, and accuracy. So by doing so, you see, this model, decision tree algorithm, is performing the best, 80% of accuracy, when you divide the data set into 80-20, and the quality measure is Gini index, because there is another one called gain ratio. So you will, this is what calling is identifying the optimal model. So for each of the machine learning model, we have to identify this optimal model like this. So for sure, demo purpose, I'm just showing you only one table. Okay. Once you identify this, similarly, you have to do for the rest of the 3 machine learning algorithms. So once done, the next one is, now you have to compare the best model of each machine learning technique. So if you see here, I have decision tree, gradient boosted, random forest, naive Bayes. So these are the 4 machine learning techniques that I'm comparing. So among this, what I found, the gradient boosted tree is the best model which can more accurately predict whether the individual household prefer moratorium or not. So what I will do in the next one, the deployment phase, I will use this gradient boosted model to predict for the unknown individuals, citizens, whether they prefer moratorium subsidies or not. So this is how things will work. So we found in this case study, the gradient boosted tree is performing the best, which is recommended for the deployment phase. So after that, if we want to see, is there any difference in the characteristics of individuals who prefer moratorium with those who don't prefer moratorium? Okay. So what we did is we apply the decision tree. You remember, we apply decision tree, but decision tree can explain how it changes the input to output. But the other models cannot explain that much. So the explainability is very less compared to the decision tree. So since we want to know more about the characteristics of those citizens who prefer moratorium, I use this decision tree to come up with the rules. So the decision tree rule says, who prefers moratorium subsidies? It says those individuals who prefers cash assistance and who do not prefer utilities discount, EPF, wages subsidies, and credit card guarantee scheme. And from which race? The races, they may be Malay, native Sabah and Sarawak, and others. As you know, in Malaysia, we have Malays, Chinese, and Indians also, right? So you see, this moratorium happened to be preferred mostly by Malay citizens, not the other races. Also, if you look at the age group, it starts from 25 to 64. So these type of people, they prefer moratorium subsidy. So this is what the findings that we get from the research. Okay. Okay. So with that, I come to end of my speech. But for this one, like Dr. Teddy, I did not use Python programming. I did not use Google Colab. Okay. So now then what is the other option? Because you see, I am teaching data analytics for business students. So the business faculty student, they are not good at programming, right? So if you don't know programming, does that mean that you cannot learn machine learning? You cannot apply machine learning? What do you guys think? Can we say only if you know programming Python, only we can do machine learning? Of course, there are differences. There are some limitations with when you do programming with the Python on your own coding, or you do a commercial or automized softwares. Because whatever the features the software is offering, you are restricted to use only those. If you want to use beyond that features anything, then of course coding is the only way. You can write your own coding, you can write your own function and to do your task and you can accomplish it. All right. But if you are a business student who said, no, I don't like programming or programming is very tough for me, but I'm interested in this machine learning, I want to apply machine learning like this and all, then you can do so, but you have to be clear with your basic data science concepts, the theory, then we can apply any of the softwares. So when you talk about softwares, we have commercial softwares and we have open source. So if you talk commercial software, we have IBM, SPSS, Modula. I do not know whether anybody heard about this. Then you have SAS Miner. These are all commercial softwares. So you have to pay money, you have to subscribe, then you can use it. Otherwise, you have also another option to start learning this machine learning, which is called open source. So in the open source, a very popular one that I am using here is NIME Data Science. NIME Analytics is a data science software, which is open source free from German company. Then we have also called Rapid Miner. This is also one of the popular data mining software, open source. So you can start learning machine learning by using this with very less programming. Okay. Okay, I think with that, I would like to end my talk. So I want to go for more question answer. So if you have more question answer, you can ask me. Yeah. So do you have any questions for me?
I think we have one question from Muhammad Hazik Zafri bin Faisal Khairi. Doctor, how about
Okay.
the pitfalls of having data bias among the among your data sets? In
Okay,
the
how would you avoid the pitfalls of having data bias among your data set? See here, the data, the one that I'm using is coming from a survey, right? So survey, this survey is coming from only 40,000 Malaysian individuals, not from the entire country, right? So definitely there will be bias. So whatever the findings that I'm extracting by applying machine learning is only applicable to this, right? So when you want to generalize, there will be some errors. Okay, so We cannot say what type of data we have. Only from that data we get insights. So the generalizability will be questionable if we don't have many data. But instead of 40,000, let's say we have 1 million data. Then you will get a better finding. So when you talk about data mining, the more is merrier, because the more data you have, you come to know more, right? Then you'll get more valuable insights. That's the logic. Okay. Okay, Yubin, what is the difference between Gini index and gain? Gain index is nothing but your gain ratio. When you learn the decision tree algorithm, you will learn how the decision tree is picking up which variable to start as a root node. Okay, so that goes to the algorithm. Since this participant is not from so hardcore technique, so I'm not going to go with the algorithms. Okay. Yes. Yes, Hazit. Okay. So it's a Friday evening. I understand. So I understand the people rush. Okay, so I don't want to take much time. So I think the intention of this short course is to make awareness of what is machine learning, what we can do, and how it looks like, what are the steps to carry out the machine learning to get the insights or business intelligence. So you have two different dimensions. Dr. Teddy, he has shown scientifically how do you able to predict whether a meat is good quality or not. All right, so he uses Google Colab and typical Python programming to explain the steps and how do you get the model and how do you do deployment. And myself, I am from the other side, coming from very, very social science example with how a government can use it. So like this, we have so many examples. If you have a company, retail company, you want to predict which customer will churn or not, whether the particular customer will like a new product or not, new service or not. There are so many things that we can do with machine learning. If you just Google it, you'll get lots of samples or applications of machine learning in every industry almost. Whichever industry, whether manufacturing industry or retail industry, anywhere you want to see, you will see applications of machine learning. All right. So if you learn this, you can work anywhere across any industry. Okay.
All right, thank you.
So thank you for the opportunity, Dr. Inda Fazavati. Thank you, Dr. Teddy.
You're welcome, Dr. Ratimala.
So let me stop presenting.
Okay, thank you very much, Dr. Ratimala Kanan and also Dr. Dedi for the talks. So I want to remind all of you participants, we have shared the feedback link in the chat box. It is also an attendees list, so kindly fill out the questionnaire because filling out this feedback is also the requirement to earn e-certificate for you, okay? Thank you. The next class would be on Monday.
The Monday will be the evaluation for blockchain and also machine learning with Dr. Dewi and also Mr. Patrick.
Okay, great. So if any of you still have problem to access Google Classroom, please email us at info@io.telcomuniversity.ac.id.
I think you can put in the chat box the email ID.
Sure. info@io.telcom. Where can the recording? Where can we get the recording, Miss? I think you can get it in the Google.
Yeah, once I get it, I will email you.
Okay.
Yes,
I'll
and
share
we
it.
will upload in the Google Classroom.
Okay.
Yes, you've been.
But I don't have the Google Classroom access, I think. Anyway, I will email to Dr. Inda and I'll get it.
Just email it to us.
Dear admin, may I know when the previous 2 classes recorded videos will be uploaded?
Yeah, the first class is already uploaded in the Google Classroom. Second is in process, and the third after we get from Dr. Ratimala.
Okay, there you go. Maybe we can take a group photo for this session with Dr. Ratimala and also with Dr. Dedi.
Yes.
Okay, everyone, if you could please open your camera so we can have a group photo with Dr. Ratimala and also Dr. Dedi. Okay. Okay. Thank you very much. So we can take the picture now. So everybody get ready on my account on 3. So 1, 2, 3. Okay, thank you very much, everyone. See you on Monday. We will send you the invitation link as usual via your registered email. Thank you one more time. Thank you again, Dr. Ratimala and Dr.
Thank you, everyone. Happy weekend.
Yeah. You too.
Thank you.
Dr. Ratimala. Mas Dedi, terima kasih banyak.
Terima kasih sama-sama.
And thank you very much to all participants. Thank you. Don't forget to fill out the questionnaire, please.